Hey everyone, Kai here. In this video, I will be discussing the quantum theory in the atom, also known as quantum mechanics. Quantum mechanics. Quantum theory is based on several models and equations that describe the relationship between electrons and their orbitals, as well as the wavelengths and particles of light that are emitted from electrons. This video will mainly be focusing on the relationship between the Bohr model and the quantum mechanical model of the atom. The model I'm about to show you guys paved the road for quantum theory, but was later disproved by another model I will show you later. Niels Bohr was a chemist who discovered that electrons can be separated into different shells or orbitals. His model contained a nucleus, as well as the other orbiting particle electrons. Let me just draw them all for you right now. Bohr model. Alright, so we'll just add a few protons here, and then we'll add a few neutrons. And then he had electrons, different layers. Just like that. Technically, I would need to draw an extra proton. This model also brought up the fact that electrons farther away from the nucleus possess more energy than if they were closer to the nucleus. So these outer electrons right here have more energy than the ones inside. At the time that idea was proposed, it was still unclear to most chemists why electrons gained energy that way. That opening gave way for the next model, which is the quantum mechanical model. Before we jump right into the quantum mechanical model, we first need to talk about physicist Erwin Schrödinger. Schrödinger believes that through mathematical equations, electrons acted as matter waves instead of particles, like so. Versus. So with this idea, Schrödinger created the quantum mechanical model. Alright, so I have the quantum mechanical model drawn down here for you guys. Quantum mechanical model. So the reason why this model has these cloud-like orbitals instead of defiant lines like the Bohr model had is because of the Heisenberg uncertainty principle. Heisenberg uncertainty principle. This principle states that it is impossible to know both an electron's position and energy at the same time. Therefore, each orbital shows the relative location of an electron about 90% of the time. The last thing I want to show you guys in this video is an orbital shape chart. If we scroll down here, I have a chart with all the different types of orbital shapes in an atom. As you can see, there are a total of 4 sections of this chart, each labeled SPDF. In my last video, I talked about SPDF blocks and their energy levels through electron configuration. Anyways, all of these orbital shapes represent the quantum mechanical model and the relative locations of electrons in specific atoms. Now, that's all I have for today on the quantum theory. I'm Kai. See you next time.